This presentation will cover basic pointers for using satellite imagery in a remote sensing project. I'm going to talk about satellite image characteristics and specifically what to consider when selecting your satellite imagery. The main areas that I will cover will be spatial resolution, spectral bands, program history, image surface area, multi-angle options, repeat intervals, also known as temporal resolution, tasking, price and licensing, browse options, processing options, and I will finish up this presentation by showing you some examples of different types of satellite imagery and cover recommended data sources for your student project. So spatial resolution is the size of a pixel in ground dimensions, and it's represented by a single value. So for example, with the Landsat imagery from your workbook, it is 30 meters by 30 meters, and that is if the pixel is square. Not all imagery comes with square pixels, but most of it does. So if we are moving into more sophisticated data analysis and going from just detection of areas to identification of specific features in the image, and then to finer analysis such as NDVI indices or looking at spectral characteristics, you're going to need finer resolution. A rule of thumb is that you can select resolution at approximately 10 times the size of the feature that you want to examine. So for instance, if you want to examine features that are about 3 meters by 3 meters, then your Landsat imagery at 30 meter pixel size is sufficient. Now, in the real world, the rule of thumb is not very useful, and here's why, is that there are many other considerations than just the size of the object that you want to examine. So you're going to need to think about characteristics such as contrast, location, shape, and other things specific to your project. So the take-home message here is that make sure you get advice from others because experience is invaluable. For this course, I want you to focus on the tools and the process of putting together a project. So I'm going to guide you to some pretty specific data sets, and I want you to explore and find other data sets, certainly, but focus at this point in your skill development on using the data that I will suggest for you unless you already have a project going and you want to use an alternative data source. And then work with me and we will put together the initial stages of your project. So with spectral bands, remember that band placement determines which colors are imaged. And when I say colors here, I'm referring to the portions of the electromagnetic spectrum that are sampled. It's not the same thing as the RGB, red, green, blue colors that you see on your computer monitor or that you experience in the world. So think back to the idea of the electromagnetic spectrum and all of the different portions of that we sample for remote sensing. Bandwidth is defined as the range of colors that are imaged for each layer, and each band will collect in certain portions of the electromagnetic spectrum. So in addition to red, green, and blue, we can also have, for example, near infrared, far infrared, shortwave infrared, etc. The number of bands determines how many different colors are imaged or represented in your image. Couple of definitions for you. Multispectral means a few or several bands, and hyperspectral means several dozen bands or more. Again, I can't emphasize this enough. Get advice from others because experience is invaluable. When you're thinking about a satellite platform, the history that you want to consider: when was the program started, how long did it run, and if it is still running, will the program continue, and are historic images still available? So as a consultant, you are going to be working with images from multiple sources, And all of these things should be considered. For the purposes of this course, you can briefly mention it in your presentation if you would like. It's not necessary to go into a lot of detail. An image will have a certain defined surface area, and this is the area on the ground that is covered. It can also be called a scene, and it is the concept of how much area is captured in that image. A larger area increases the chances that your study area falls on fewer images. So for instance, if you are sampling, say, a national park, Kruger National Park in South Africa, you may be able to get Landsat images that encompass and include the entire park in one scene. If not, you're going to need to mosaic your images together. Greater coverage reduces the problems associated with mosaicing multiple images. So when you mosaic images, you need to consider factors like color matching, geometric matching between the data collections, and different seasons if you are getting your images from different days and times. With multi-angle options on sensors, you have the ability to point your sensor, and this allows you to select a specific location and a specific time. This improves the ability to target specific areas instead of the systematic collection. This is commonly used for military reconnaissance and for public safety, like homeland security. It's also used to track disasters such as hurricanes, earthquakes, storms along the beach, and erosion, and many, many other examples. Multi-angle options can be used to collect stereo pairs and for the creation of a digital elevation model. The off-angle viewing distorts the image, although this is compensated for during processing. And effectively, your multi-angle options will shorten your repeat interval, or how long you need to wait in order to get another image. So what's a repeat interval? Okay, we've defined this as temporal resolution, and it's the minimum time a particular feature can be recorded twice. Short repeat intervals increase chances of acquiring a clean image. So if it is important for your project objectives to get an accurate representation of a certain time, say you want to do before and after a storm hits a beach area, for example, you need to have a very, very short repeat interval in those images that you are using. Now, this is not the same thing as anniversary dates, so your before image can be a little bit less rigorous on when you need that time sampling, but your after image, if you are, for instance, analyzing the amount of erosion that took place from a hurricane, you need a clean image, and you don't want to create a composite from images that are far apart in time. So a special note, most satellite orbits do not pass over the poles, and so these data cannot always be acquired. If you are going to go into polar research, there are satellites available to you, and they are generally not free and publicly accessible. With tasking, many satellite remote sensing systems can be tasked to acquire imagery on a specific date or time period. Tasking can be expensive, and this is higher-end GIS work. As an analyst, you want to make sure you read the small print of the agreement and understand what acceptable means. Factors that you would consider are percent cloud cover, time frame, number of attempts of sampling, etc. With price and licensing, image prices can range from free to greater than $100 per square kilometer. Some imagery can be distributed free of charge, and at the end of this presentation, I provide you with a sample of imagery that is free and relatively user-friendly. There are many, many sources available, and Google is a very powerful tool that you can use to search out imagery. I'm going to point you to some free sources. Keep in mind that many commercial companies only license their imagery so that a user never owns the data. You pay a fee in order to use the data. So, for instance, with commercial imagery, sometimes the imagery that is used in our teaching, for example, is not to be distributed amongst students or even on your home computers unless you have a license. Licensing agreements define how the imagery can be used and distributed, so make sure that you check that license agreement. With browse options, most image providers have powerful browse capabilities with tutorials. Oftentimes there will be a very user-friendly interactive map, and you can define your study area, you can define the date, you can define special parameters of your image such as cloud cover. Some systems have historic imagery scattered around the world at ground receiving stations. Regional centers sometimes have browse capabilities for a variety of remotely sensed imagery, and researching is available to you, and but researching imagery can be time consuming. So if you're interested in multiple image types, you want to really focus your efforts and not spend too much time looking at all the possibilities. Refer back to your objectives and become very focused on what it is that you're searching for. With processing options, these can be a bit confusing. Most vendors provide a variety of radiometric processing, which is adjusting the colors that you see, remembering that colors also includes visible colors and infrared, near infrared, microwave, etc. And vendors also provide geometric processing, which adjusts the image so that it matches a particular orientation or a specific map project. The simplest processing uses onboard calibration and orbital models. So the engineers that design your satellite platforms include onboard calibration and software that is considering the orbits, the sun azimuth, the angles, time of day, and many other factors. As a GIS analyst, you can use off-the-shelf ancillary data such as a digital elevation model or user-supplied data to improve the geometry of your image. With appropriate software skills and experience, data users can do their own radiometric and geometric processing. So even with pre-processed imagery, a user may have to do additional processing if the imagery is to be combined with other spatial data. A quick review of types of satellite imagery: two main categories, passive sensors and active sensors. Passive sensors use sunlight for energy source, and they're defined here into three categories based on resolution size: low, moderate, and high. Low resolution is greater than 100 meters, and this includes MODIS, AVHRR, and spot vegetation. Moderate resolution would fall in the 15 to 100 meter resolution category. It includes all of the Landsat satellites, including the TM and ETM plus the numbers 1, 2, 3, 5, 7, and 8. Spot, Aster, and IRS. And then finally, high resolution is less than 10 meter resolution and includes Iconos, QuickBird, OrbView, IRS, Spot, and Corona. In general, your higher resolution images are going to be costly. And the other type of category is active sensors, and this is imagery where the energy was generated. And two examples are radar and LiDAR. So with radar, we could search out RadarSat, ERS, EnviSat, and space shuttle imagery. With LiDAR, only airborne platforms are available for now. If you're interested in working with LiDAR data, I suggest the ESRI training materials. They have online courses and they have workbooks in how to use LiDAR data. So here are some examples of imagery. I'm just going to briefly describe the image and give you an example or two of applications. So this is a composite image that was acquired from multiple scenes collected between June and September 2001. These have been put together into one image, and this could be used for looking at crop health. It could also be used for looking at carbon consumption and carbon fluxes and estimates of global patterns. This is a Landsat ETM image. It's a 30-meter resolution. It's color-coded here so that certain parts of the vegetation appear in pinks and purples. This could be used for analyzing forest health, and it could also be used as a pre-image for assessing fire damage. This is an aster image with 15-meter resolution. It's been false color coded, so vegetation appears in reds and water appears in blues. This type of image could be used to assess flood damage. It could also be used to focus on urban expansion. And if you look in the upper left-hand portion of this image, you can see that there is an urban area that is also color coded in blue. This is a corona image, 5-meter resolution. This would be an image that you would purchase, and it is a historical image from 1967. This might be used in a project that was analyzing the river dynamics and the hydrology of this particular area. It could also be used for urban expansion to assess land cover. This is an Iconos pan merge, and there is a 1-meter resolution associated with this image that was taken in April 2002. The vegetation appears in red, and you can see particular features such as tree stands, and you can also see geometric features, water bodies, and natural areas. There's also an urban area in this image, and if we focus in and zoom in on that, you could see that this type of image could be used for urban analysis. You could get detailed analysis such as amount of pervious versus impervious surfaces. So pervious surfaces would be your roads, your roofs, and urban areas like parking lots. You could also use this type of imagery for flood analysis and vegetation purposes. So what if traditional imagery is not available? Here are some options that you can consider. Look for less common data sets such as aerial photography, corona imagery, airborne imagery such as AirSAR and AVARIS, research satellites and sensors like Hyperion and Advanced Land Imager, which you might hear as ALI, astronaut photography, radar, and LiDAR. Don't be afraid to modify your analysis methods and/or study area if you can. If you are contracted, you may not be able to do that, and you would invest more time in searching. As a student, don't hesitate to modify your analysis method or study area if finding imagery becomes a challenge. And again, you can also modify your project objectives. Remember, when you're learning new skill sets, don't spend a lot of time in the research and searching process. A little bit of time, and if you find that you are getting frustrated and you are running out of time, please consult with your instructor, and I will focus you to finding imagery. Here's an example of an astronaut photo for Andros, Bahamas. And this could be used for many applications. Another example of an astronaut photo. And I just want to point out that the difference in this photo from the prior one is that there is some cloud cover in this image. And you need to decide what is acceptable cloud cover. If you wanted to be analyzing the roads that you can see in this image, this may be too much cloud cover for you. However, if you wanted to analyze the intertidal area that you can see in the top of the image, this would be a very acceptable amount of cloud cover because that portion of the image is not going to be in your final analysis and it doesn't affect your project objectives. Here's an example of 2 different platforms that collected images that are used that collected images at the same time. On the left, we have a Landsat ETM Plus image, and on the right is an ALI image, and this is for Kruger National Park in the Republic of South Africa. And they are representing different surface areas. The scenes are different, so the amount of coverage for each of these images is different, and they could be used in the same project. This is an avarice image, and you can see that urban areas are shown in bright blues, and we see a road, several roads, and we also see water bodies and then plots of land. Remember that man-made features tend to be geometric, and natural features tend to be rougher or more unpredictable in shape. Here are some sources for data, and I have 2 slides for you. Please make sure that you refer to the PowerPoint slides that are also available on Blackboard for these specific sites. Again, just another set of sources for you, of data. And just to conclude, how do you decide which imagery to use? Well, image availability and cost are the 2 primary limiting factors. As a consultant, you'll always want to keep your eye on the cost, and as a student, you want to focus on moving forward with your project and finding suitable imagery that matches your objectives. It's easy to get lost in the details, so use common sense and don't spend too much time being frustrated. Get advice from someone with experience. I am more than happy to work with you on finding imagery for your project. The suggested data source for this course is the USGS Earth Explorer. Please see instructions posted on Blackboard for creating an account and finding imagery. This is almost global coverage of imagery with the exception of the poles, North Pole and South Pole. A special note on Landsat 7 ETM Plus. This platform was broken on May 2003, and so there are lines in the images. You can see this here. If you choose to use Landsat 7 ETM Plus imagery, you need to know that there are a great deal of errors that are caused by gaps in the image. It starts at the center and becomes wider at the edges. Please read more at this website here on this error and methods for correcting it. So just very briefly, there is a way to correct for the error. On the left, you can see that there is an image from April 2004 with errors in it. On the right is an image from April 2003 without errors, and then those are combined at the method that is detailed on the link provided, and it essentially corrects the gaps. Now, for the purposes of this course, you don't need to take on that challenge, and some scientists do not feel comfortable with using this method because, in a sense, if you're interested in what happened in April 2004, the conditions in April 2003 were very different. So again, think about your objectives of your project and if this method is going to be appropriate for you.